In this video, we're going to give examples and explain concepts and terms related to exponential modeling. Let's go ahead and get started. Describe the meanings of all variables in the exponential function q equals q naught times 1 plus r to the t. Explain how this function is used for exponential growth and decay. B, r is equal to the fractional growth rate for the quantity or decay rate, and d, t is equal to time. And let's explain how the function is used for exponential growth and decay. Choose the correct answer below, select all that apply. The function is used for exponential growth if r is greater than 0, and the function is used for exponential decay if r is less than 0. Just to remind you what the different values are here. Q is the quantity at time t. Q naught is the initial quantity at time 0. We already talked about R is the fractional growth rate or decay rate here. It's going to be negative if it's a decay rate, so that this number inside the parentheses will be less than 1 if it's decay, and it will be greater than 1 if it's growth. And t is the time. Briefly describe how exponential functions are useful when modeling inflation, environmental and resource issues, physiological processes, and radioactive decay. So there are cases where the absolute growth rate is not constant, but the relative growth rate is constant. So exponential growth and decay can be used to model these situations. Relative growth or decay rate means that it's proportional to the amount of stuff that's there. So the more, for instance, with population growth, the more people that are there, the faster those people are going to grow. The less people that are present, the slower they're going to grow, negating all other factors such as predators and resources like food and space to live in and those types of things. We would need more complicated models for that, but based only on the variables of population and time, that the more that the population grows, the faster the population grows. Radioactive decay rate, for instance, is the more stuff that's there, the faster that it's going to decay. Even something as simple as how long it takes for the cake to cool as it comes out of the oven is an exponential decay rate that's based off of the difference between the temperature of the cake and the air temperature of the room. And the bigger that difference is in temperature between the cake and the room temperature, the faster the cake is going to cool. As it gets closer to room temperature, it's going to cool more slowly. So that's why you need to know how to do math for things like that, even to know how long you need to let something cool when it comes out of the oven. Very practical exponential growth and decay rate models here for real life. Plenty of things in real life that they model. All right, we'll come back next time and keep talking about 9C. See you for the next video.